Good day. Today I will present my ODE project. The code is BEE11203. I am from section 2, group 1. So this is my team member. They have Betty Cheng, is me, Jia Keke, and Ding Xing Yi. This is our project contents. They have two. First is method users, and the second is discussions and solution. We use two method users to complete the project. First is manual calculations, and second is MATLAB.
I'm Ding Xing Yi, AE230061. I would like to present the discussion and the solution. For the question 2, we have mentioned that by using the undetermined coefficient method, we need to find the complementary function yc for the corresponding homogeneous equation. So from the equation that given, we can get that m squared minus m minus 12 is equal to 0. By using the factorization, we can get that m is equal to 4 and minus 3. So yc is equal to ae to the power of 4x plus be to the power of negative 3x. For question 2, we are asked to determine the particular integral yp. So from the equation given, we can identify that fx is equal to 5e to the power of 4x, which means yp is equal to ce to the power of 4x. So we can know that yp is equal to yc. Therefore, yp have to times x, so that the final yp we can get is cxe to the power of 4x. For the question 3, we are asked to write the general solution for the second order non-homogeneous ordinary differential equation with initial condition when x is equal to 0, y is equal to 1, while x is equal to 0, y prime is equal to 1. We can get that yc is equal to ae to the power of 4x plus be to the power of negative 3x, and yp is equal to cxe to the power of 4x. We have to differentiate yp so that we can get ce to the power of 4x plus 4cxe to the power of 4x. Then we have to differentiate yp again, that we can get fce to the power of 4x plus 16cxe to the power of 4x. We have to sub the y double prime p and y prime p and yp into the equation given, so that we can find the value of c, which is 5/7. After that, we have to find the general solution with the formula y is equal to yc plus yp, which is the final answer we can get is ae to the power of 4x plus be to the power of negative 3x plus 5/7 xe to the power of 4x. Then we need to find the value of a and b from the initial condition given, which is x is equal to 0, y is equal to 1, and x is equal to 0, y prime is equal to 1. So from the general solution above, we can identify two simultaneous equations, which is a plus b is equal to 1, 4a minus 3b is equal to 2/7. So we can get the value of a and b, which is 23/49, and b is equal to 26/49. So the final general solution we can get is y is equal to 23/49 e to the power of 4x plus 26/49 e to the power of negative 3x plus 5/7 x e to the power of 4x. For the part B, we need to calculate the general solution by using the method of variation of parameter. At first, we need to determine the value of a and fx, which is a is equal to 1, fx is equal to 5e to the power of 4x. Then we need to find the y1 and y2 from yc. yc we can get is ae to the power of 4x plus be to the power of negative 3x. So y1 is equal to e to the power of 4x, y2 is equal to e to the power of negative 3x. After that, we need to find the value of Wronskian w with the formula provided, which is w is equal to negative 7e to the power of x. After that, we need to find the value of u and v. With the formula, u is equal to negative integral y2 fx over aw dx plus a, while v is equal to y1 fx over aw dx plus b. the value of u we can get is 5/7x plus a, while v is negative 5/49e7x plus b. So we substitute the values into the equation y is equal to u y1 plus v y2. Then we can get the answer is a e to the power of 4x plus b e to the power of negative 3x plus 5/7x e to the power of 4x minus 5/49 e to the power of 4x.
So this is the mallet coding for question 2.1, and now we will try to run the coding first. Here is the output from the coding. The question asks us to find the complementary function yc. Before starting to do this question, we need to define the equation of parameter to determine the root. From this coding, we get the answer of root are 4 and negative 3. Then the suitable formula that we will use to find the yc is case 1. This because it's not same value of root 1 and root 2. So the final yc we get from the MATLAB is a exponent power 4x plus b exponent power negative 3x. Next is the coding for the question 2a2. Now we will try to run our coding first. From this output, we can know that the RHS mean right hand side is our yp function. We declare the yp function via the table given in the ODE books. So we do the comparison between yp and yc. The output given are overlapping. So the new yp function need to times x to different yp and yc. So the new yp we get from the coding is cx exponent 4x. So this is the coding for the question 2a3. Now we also run the coding first. From the output, we know that the new yp is cx exponent 4x. So we do the first differentiation. So the output we get is c exponent 4x plus 4cx exponent 4x. And then we second differentiation again. So the output we get is xc exponent 4x plus 16cx exponent 4x. So we know that the f function we get from the previous coding is 5 exponent 4x. So the new equation we get is 7c exponent 4x equal to 5 exponent 4x. So by this equation we can find the c value. So from the output we know that the c output is 5/7. So we substitute inside the yp function. So we get the yp function is 5x exponent 4x over 7. So the general equation we get is by adding yc and yp formula. So the final general solution we get is 5x exponent 4x over 7 plus a exponent 4x plus b exponent negative 3x. So by the general solution, we do again the first differentiation. So we get the first differentiation answer is 5 exponent 4x over 7 plus 20x exponent 4x over 7 plus 4x exponent 4x minus 3b exponent negative 3x. So by these two equations, the general solution and the first differentiation equation, we can conclude two equations. The first equation we get is 1 equal to a plus b, and equation 2 we get is 1 equal to 4a minus 3b plus 5 over 7. After that, we apply the initial condition y0 equal to 1 means x equal to 0, y equal to 1. Apply in the two equations. So we will get the answer for a and b. From the output, we know that the a we get is 23 over 49, b is equal to 26 over 49. So the final answer of the general solution we get is y equal to 26 times exponent negative 3x over 49 plus 23 exponent 4x over 49 plus 5x exponent 4x over 7. So this is the coding for the question 2b, so we will run the coding first. After run this coding, we get the output. The particular solution of relation of parameter we get from the output is exponent 4x times a plus 5x over 7 plus exponent minus 3x times b minus 5 exponent 7x over 49. So this is the answer from the MATLAB we get for this question.
So I would like to compare the final answer of the manual calculations is equal to the output of the MATLAB. So for the question A1 is find the homogeneous equations of YC equal to A exponent power 4x plus B exponent power negative 3x for manual calculations, and the output for the MATLAB is same. So for the question A2, find the particular integral of yp. The yp equal to cx e exponent power 4x. So this same as the output of the MATLAB. For question 3 is find the general solution of the second order non-homogeneous ODE with initial condition y equal to 1, x equal to 0, and y prime equal to 1, x equal to 0, and the final general solution equation is y equal to 26 over 49 exponent power negative 3x plus 23 over 49 exponent power 4x plus 5 over 7x exponent power 4x. So the manual calculations and the MATLAB output is same. So for the question B is find a general solution by using method of variation of parameters, and the final answer is y equal to a exponent power 4x plus b exponent power negative 3x plus 5 over 7x exponent power 4x minus 5 over 49 exponent 4x, and the manual calculations and the output of MATLAB is same. So I cross that our manual calculation and the output of the MATLAB is same, so our final answer is quite correct. That's all for our group presentations. Thank you.